I'm Anil Kumar, and here is question number 5 from Amandeep's test paper, grade 11 MCR3U. It is on transformation of the function. Well, I'll sketch a rough graph for you and explain you how to answer this question. Let's understand the question in details. Question here is, consider the function y equals to half to the power of minus 2x plus 3. Sketch graph of the function with asymptotes and y-intercept. State its domain and range. You can pause the video, answer the question, and then look into my suggestion. It will help you to prepare for your test. Okay, now here we have half and to the power of minus 2. Now half is a decaying growth, exponential growth, and minus 2, if we rewrite this function, it becomes simpler for us, right? So what I will do here is I'll rewrite the function. So the function will be y equals to 2 to the power of, that is because of this minus 2x plus 3. Do you see that? Once you do that, it becomes simpler for you to understand and also to sketch, correct? Now we will sketch this function, which is same as the given function, right? I haven't really changed the function. Okay. Now here let's find the horizontal asymptote. As you know, every exponential function will have horizontal asymptote, right? So horizontal asymptote is when x approaches, for this case, minus infinity, right? When x approaches minus infinity, right? A negative large value, exponential part of this approaches 0. What happens to y? So y approaches 0 plus 3. So y approaches 3, and therefore we have a horizontal asymptote whose equation is y equals to 3. So let me first sketch the horizontal asymptote as such, which is, let us say, like this. Let's say this is our 3. So we will write this as y equals to 3, right? So this point is 3 for us. So here we have x and that is y. Now we also need to find the y-intercept. Y-intercept is the value when x is 0, right? So to find y-intercept, let me write y-intercept. That means x equals to 0. So we'll substitute 0 here. So we get y equals to 2 to the power of 2 times 0 plus 3, so which is 1. So that will give us 1 plus 3, which is 4, right? So the y-intercept is, if this is 3, y-intercept is 4, right there. So we get the y-intercept also. Now to sketch the function, what you should do is, you should make a table of values. That is to say, write some values for x and calculate y, correct? So take some values of x. I'm not doing the calculation here, but I'm just telling you the method like this. So you could take some values as, in this particular case, you could take values as minus 2, minus 1, 0, 1, 2, and so on, right? Some values. So you'll get y values, plot them on your graph, and what you'll observe is a graph which is going to go like this. So that is how your graph is going to be, right? So to describe this graph has horizontal asymptote at y equals to 3, and it has been horizontally compressed by a factor of half, right? Horizontally compressed by a factor of half, and that is how it is going to look, right? So you can take some values and then plug it in. So that is how you'll get fairly accurate graph for this particular function. I hope that helps, right? For example, if we already have x equals to 0, we have one value. If I substitute x equals to 1, 2 to the power of 2 is 4, 4 plus 3 is 7, correct? So you get this point. X equals to 2, so 2 to the power of 2 times 2 is 4. So 2 times 4 is 16, 16 plus 3 is 19, right? We know 2 to the power of 0 is 1. Minus 1 means 1 over 2, that means square root, right? So you can calculate these values, which are very, very small, and then you can plot your graph. That's the whole idea, right? So that is how you should be doing it. Thank you and all the best.